How circles curve compared to a flat line. Let's take a look at our circle. We're going to compare this circle with this flat line. The circle has the same radius as our planet Earth. So what we're going to compare is how I go to the right, how far I go, how much drop will there be. It has a radius of 3,959, and I moved it down the same amount of units so that my circle would share the origin. So that way I could exactly tell as I went to the right how many miles, then how many miles would I have to go down to touch my circle. And that way we could sort of look at curvature. Notice my circle's radius, about 4,000 miles. That's exactly what we want. And if we look at circles, they all share this attribute. The curve moves slowly at first in this section, then the curve speeds up in this section, and then now the curve is going so fast it's almost a straight line, straight drop in this section. But when is that curve noticeable, I guess, is what we want to look. If I go to the right 100 miles, I drop 1.3 miles. Okay. That's significant. Travel 100 miles to the right, I drop 1.3 miles. Here's our Excel spreadsheet that has the same data as our graph, but now we have it in table form. It's a little easier to look at. My chart said, what happens at 40 miles? Let's do 20 and then let's do 40. We can use our spreadsheet as sort of a predictor. You can say, how many feet will I drop? So if I drop, let's go, say, if I drop 100 feet, then how many miles did I go to the right? Well, about there. So I went 12 miles to the right, dropped about 100 feet, between 12 and 13. So this is good in its predictive value. You could also say if I travel 20 miles to the right, how many feet will I go? Will I drop? 266 feet. Now that 266 feet is also both ways. So if I travel 20 miles to the right, I drop 266 feet, or to the left. And now remember that 0.06, that's actually miles, not feet. All right, what about 40? When I travel 40 miles to the right, I drop about 1,000 feet. Now let's really put our predictive chart to the test. Let's take something we already know, like something super flat, and let's see how much it curves, like Kansas. Everyone knows Kansas is pretty flat. Alright, so first let's measure Kansas. How far is Kansas across? The chart says about 400 miles. 400 miles to the right, 20 miles down. Now that seems like a lot, doesn't it? 20-mile dip. But consider something for a minute. Let's go back to Kansas. I can see to the moon from my house, so I should be able to see pretty far away. Here's a couple videos of people driving through Kansas, listening to your tunes, windows open. There's got to be a couple more. Driving through Kansas, another one.
So this is Kansas. This is Kansas. Wow. I'm in hell.
What I'm pointing out in these videos is even as flat as Kansas is, you can only see so far. If Kansas were truly flat, one would think just like the moon, barring atmospheric, what do you call that, disturbances, things in the air that prevent me from seeing as far as I could see. But on a perfectly clear sunshine day with nothing in the atmosphere, shouldn't I be able to see all across the state just like I can see to the moon? Alright, let's try another video. Driving through Kansas.
Here we are in Salina, Kansas.
It's awesome here. So
Here's
sunny.
Elliot.
So beautiful. It's absolutely wonderful.
It's about 9 o'clock. The sun's coming up.
Do it.
There's a lot going on here.
How far away is Salina, Kansas from, if we got down here, we got Kansas City. So this is, a big city with super tall buildings. If Kansas were truly flat, you would think you'd be able to see those buildings from Salina. From Salina, Kansas to Kansas City, it's about 160 miles. To the charts. Let's see what that means. Let's see what we can predict. So about 160 miles. If I go 160 miles to the right, I drop down about 3.2 miles. So what does that mean? That means Kansas City is below the horizon about 3.2 miles. There, right about there. If I travel 160 miles to the right, I drop down 3.2 miles. Now that feels significant, but consider driving through Kansas. You can't see very far at all. You can only see over the next hill or the next farm. Here in Washington State, we have eastern Washington. It's pretty flat as well. It's our wheat basin where we grow all our wheat there in that area. It's pretty flat, but you know what? You can't see past the next farm because the horizon keeps dropping in front of you. You're never going to see it. You're never going to catch up. So the idea is, and thank you, Vadir, for giving me this idea. If you can see the moon from your house, we know we can see long distances if the atmosphere doesn't get in the way. So I should be able to see long distances on planet Earth as well, like from Salina to the tall buildings of Kansas City. But the problem is I can't see from Salina to Kansas City because there's over a 3-mile drop over the horizon. As I go to the right 160 miles, I go down 3 miles, which makes seeing it impossible.